Let us look at the next section, students. This section contains 2 paragraphs. The first paragraph has 3 questions and the second paragraph has 2 questions. Each question has 4 options, out of which one or more than one option may be correct. So let us look at the comprehension given for question number 31, 32 and 33. Okay. A white amorphous powder A on heating yields a colorless non-combustible gas B and a solid C. The latter compound assumes a yellow color on heating and changes to white on cooling. So students, this gives us a hint that this compound may be ZNO. So ZNO on heating, it changes its color to yellow, and when it is cooled down, it changes its color to white. Further, it is given to us that C dissolves in dilute acid to give a white PPT with K4 FeCN6. So this is another confirmation for zinc, students. With K4 FeCN6, zinc 2 plus ions, they give a white precipitate. If we talk about the next information, A dissolve in dilute HCl with the evolution of gas G. It has to be a salt of zinc or a compound of zinc. Okay, it is further given to us that the gas B turns lime water milky, but the milkiness disappears with the continuous passage of gas. So a non-combustible gas which turns lime water milky and the milkiness disappears on continuous passage of the gas. This has to be CO2, students. So we must have had a carbonate. We must have had ZnCO3 or something like that. This further given to us that the solution of A as obtained above gives PPT-D on the addition of excess of NH4OH and passing H2S. Okay, so this is another confirmation for zinc, students. Zinc is present in the group 4 and it is precipitated by passing H2S in the presence of NH4OH. And it is further mentioned to us that another portion of the solution gives initially a white PPT-E on the addition of NaOH solution, which dissolves on further addition of the base. So it is clear to us, students, that the salt under consideration is ZnCO3. So we can just write the reactions. So ZnCO3 was the white amorphous powder. Upon heating, it gave me ZNO plus CO2. So this CO2 is the gas B, which is non-combustible, and this ZNO is the solid C. Okay. It is given to us that this ZNO becomes yellow upon heating and it becomes white upon cooling. So this has to be ZNO. We have seen that this is the property of ZNO itself. Okay, so white upon cooling. It is further mentioned that C dissolves in dilute acid to give a white PPT with K4 FeCN6. So this is correct, students. ZNO is amphoteric. So this ZNO will dissolve in dilute acid to give us zinc 2 plus ions, and that zinc 2 plus ions will react with K4 FeCN6 to give us a white PPT. Okay. It is further mentioned to us that A dissolve in dilute HCl with the evaluation of gas G. So when it is allowed to react with dilute HCl, so there will be an acid-base reaction happening. So zinc chloride will be formed along with the liberation of CO2 and H2O. So H2CO3 will be formed, which will dissociate and liberate CO2. So this gas G is also CO2 again, students. So we have already established that the gas B was CO2. It was non-combustible and it turned lime water milky, which disappeared upon continuous passage of the gas. Okay. Now it is given to us that the solution of A as obtained above gives PPT-D on the addition of excess NH4OH and passing H2S. So when this zinc 2 plus ions are allowed to react with H2S in presence of NH4OH, we have a precipitate of ZnS, which is white in color. Okay. Another portion of the solution gives initially a white PPT of E. So we are dealing with zinc 2 plus now. So ZnCl2 plus NaOH. It gives us ZnOH whole twice. So which is white in color again, students. It dissolves in excess of NaOH to form the tetrahydroxozincate complex. So Na ZnOH whole 4. We're going to have Na2. Okay. So this is the clear solution. So we are now in a position to solve this question, students. So question number 31, it says, which of the following ore may represent the white amorphous powder A? So we have seen that A was ZnCO3, and if we talk about the ZnCO3, it can be calamine. Okay, so ZnCO3 is calamine. So for question number 31, we have to mark the answer as A. Let us look at the next question now. Question number 32. Which of the following statements correctly relates to the properties of gases B and G? So we'd seen that B and G were both CO2. Okay. Option A, it says gas B is non-combustible whereas gas G is combustible. This is not correct. If you talk about the second statement, both the gases B and G are non-combustible. This is a correct statement, students. CO2 cannot be further oxidized. Okay. If you talk about statement C now, G represent water vapor. This is not correct. And option D is also not correct because it says that gas B is the water vapor. So out of these given options for question number 32, we have to mark the correct answer as option B. Let us look at the next question now. Question number 33. Identify the statement which is or are correct. Okay. So option A, it says color of PPT D and E is same. So students, if we talk about the PPT D, so PPT D was ZNS. And if we talk about the PPT E, it was ZNOH whole twice. So both of them are white in color, students. So this will be a correct statement. If we talk about option B now, coordination number of the metal in the solution obtained by adding NaOH in E is 4. This is correct, students. We had seen that it is going to give Na2ZNOH whole 4. So a tetra coordinated complex of zinc will be obtained. So this is correct. If we talk about option C now, the yellow form of solid C has incomplete 3D configuration. So solid C yellow form was ZNO. Okay, so this has a complete 3D configuration. Zinc is present in a state of +2. So D10 configuration is present in zinc. Okay, so this is not correct. It has a complete 3D configuration which is not mentioned in the statement. If you look at the last option now, students, oxidation state of metal in both D and E is same. So students, D was ZNS whereas E was ZNOH whole twice. So oxidation state of zinc in both these compounds is +2. So this is also a correct statement. So for question number 33, we have to mark the correct answer as option A, option B and option D. Let us look at the next paragraph now, students. This paragraph is for question number 34 and 35. Okay. So it says binary compounds of the elements with hydrogen are called as hydrides. The type of hydride which an element forms depends upon its electronegativity and hence the type of bond formed. While there is not a sharp division between ionic, covalent and metallic bonding, it is convenient to consider hydrides in the three classes, which is ionic, covalent and interstitial. Okay. Let us look at question number 34 now. Identify the correct statements about the ionic or the salt-like hydrides. Okay. Option A, it says the lattice of these hydrides are known, in which H- forms the lattice and as cation like Li plus occupying the holes in the lattice without distorting the metal lattice. So this is not correct, students. What happens is the hydride ions, they are present in the interstitial sites of the metal forming the lattice. If we talk about option B now, hydrides like CH2 are soluble in the melts of alkali halides. So this is correct statement, students. This is based on the concept of like dissolves like. So both of these are polar in nature and as such CH2 will be soluble in the melts of alkali halides. If we talk about option C now, melt of LiH conducts electricity and when it is electrolyzed, H2 will be liberated at anode. So this is the correct statement, students. When molten LiH is electrolyzed, Li and H2 will be liberated at the cathode and the anode respectively. If we talk about the option D now, density of these hydrides is greater than that of the metal from which they are formed. So this is a correct statement, students. For salt-like hydrides, what happens is the H-, it occupies the interstitial sites without distorting the lattice. Okay, so due to which the mass inside the lattice increases and as a result the density also increases. So for question number 34, we have to mark the correct answer as option B, C and D. Let us look at the next question now. Let us look at question number 35, students. Identify the statement which is correct. Okay, so group 13 hydrides are electron deficient and exist in polymeric form. So this is the correct statement, students. Group 13 hydrides, aluminum hydride, etc. they are electron deficient and they exist in polymeric form. If you talk about option B now, HN3 is electron deficient hydride. So this is not correct statement, students. In HN3, which is the hydrozoic acid, all the elements have their complete octet or duplet. Okay, so we can just draw the structure of N3H. So this is the structure of N3H, students. We can see that all of these atoms present in this compound have their complete octet or duplet of electrons. So it is not electron deficient. If we talk about option C now, metallic hydrides are less dense than the parent metal. So this is also a correct statement, students. So in the metallic hydrides, what happens, students? Due to inclusion of hydride inside the lattice, there is distortion in the lattice of the parent metal. So as a result, the density, it decreases due to increase in the volume. Okay. If you talk about the last option now, because of the inclusion of H2 in the metallic lattice, this makes the metallic hydrides brittle. So this is also a correct statement, students. Because of the inclusion of H2 in the metallic lattice, there is a distortion in the lattice, and due to which the metallic hydrides, they become brittle. Okay. So for question number 35, only statement B is not correct. So we have to mark option A, option C and option D as the correct answer to question number 35. Okay. Let us look at the next section now, students.